Anytime you're dealing with a function that has an odd power, anytime you're dealing with odd-powered functions, the graphs are going to have end behaviors that are opposite each other. So this right here is the function x cubed. Okay. If you put a negative in front of this function, so if you're looking at a minus x cubed, what do you think this negative is going to do to your graph? It's going to flip it. So now it's going to look like this. Okay. Let's look at a linear function. Again, f of x is equal to x in a linear function. Our graph looks like this. What is it going to look like if we put a negative in front? It's going to be flipped. Okay, so anytime you're dealing with an odd-powered function, so if the degree is odd, okay, there's several possibilities. Okay, so you have to identify the degree of a function, then you also have to identify whether the leading coefficient is positive or negative. So if the degree is odd, and the leading coefficient is positive, then the graph is going to open up to the right and down to the left. Okay. On the other hand, if your degree is odd and your leading coefficient is negative, then the graph is going to open down and to the right and then up to the left. Okay. Which of these graphs is the easiest just to remember, or if you had to recreate it visually just really quickly? Right. Yeah, this one right here, right? F of x equals x. You could just plug in numbers, right? X is 0, y is 0. X is 1, y is 1. X is 2, y is. So you see it's going up and to the right, and the left behavior is going down and to the left. Okay, this is true of all odd-powered functions. So if I gave you something like this, and I gave you a function 3x to the fifth plus 2x squared minus 1. And I asked you to identify the left and right behavior. What do you know about the left and right behavior of this graph? It's going to go, the left is the left going to go up or down? It's going to go down to the left. And to the right, it's going to go. Okay, now again, you don't know what's happening in between here. So I kind of draw the dashed lines to represent. You don't know what's happening, but you do know that to the left it's going down. To the right it's going up. And you know that because it's an odd power. So the end behavior is going to be opposite each other. And it's a positive leading coefficient, so it's going to go up to the right, down to the left. If I had changed this just by putting a negative in here, now what's going to happen? Yeah, it's going to go down and to the right. Again, you don't know what's going to happen in here, but it'll go up and to the left if you have that negative there. Okay, so that's true for all odd-powered functions.